Statistics is everywhere, in sports scores, weather forecasts, and your grades. As you watch, try to spot one example from your own life for each term we cover. Quick check. For scores 70, 80, 85, 90, 100, the mean is 85 and the median is also 85. They won't always match. Think about which is more useful when one score is unusually low. A dataset can have more than one mode. That's called bimodal or multimodal. The range is quick to find, but watch out. One extreme outlier can make it misleading. Picture two classes with the same average of 75. Class A scored 70 to 80. Class B scored 40 to 100. Same mean, very different standard deviations. Focus on the concept before the formula. Key difference from a bar chart. Histogram bars touch because the data is continuous. Try sketching one using your screen time across 7 days. Pie charts work best with a few categories that sum to 100%. If you have many similar-sized slices, a bar graph is clearer. Always ask, is this the right chart for this data? Line graphs show change over time. Scatter plots show relationships between two variables. Mini challenge, sketch 6 that suggest a positive trend. Key mantra, correlation is not equal to causation. Ice cream sales and drowning both rise in summer. That doesn't mean one causes the other. A probability of 0.5 is a 50/50th chance. The key question for any sample, is it representative? A survey of only your friends might not reflect your whole school. Always ask, who is left out? Don't delete outliers. Investigate them first. Ask, is this a data error or a real finding? Remember, the mean is sensitive to outliers, but the median is not. The bell curve shows up in height, test scores, and measurement errors. About 68% of values fall within one standard deviation of the mean. Can you think of a trait in your school that might follow this shape? Income is right-skewed. A few very wealthy people pull the mean up, which is why median income is often a fairer measure. If you scored in the 80th percentile, you did better than 80% of test takers. A box plot shows 5 values at once. Min, Q1, median, Q3. Max dots outside the whiskers are outliers. Try finding Q1, Q2, Q3 for any 8 numbers you collect. IQR covers the middle 50% of data, ignoring extremes. MAD challenge, 4.2, 4, 4, 6, 8. The mean is 4.8 and the MAD is 1.76. Try it yourself. Random error averages out over many trials. Bias does not. It always pushes in the same direction. Next time you read a headline, ask, could the wording or method introduce bias? 48% support this policy. Plus or minus 3% means the true value is likely 45 to 51%. Larger samples give smaller margins of error. That's why national polls survey thousands of people. A hypothesis must come before the data, not after. The sample mean is your best estimate of the population mean, and it gets more accurate as your sample grows. Law of large numbers. Standard error equals standard deviation divided by square root, sample size. Doubling your sample size reduces the standard error by about 30%. Bigger samples equals more precise estimates. Regression finds the line of best fit to predict one variable from another. The correlation coefficient R runs from -1 to +1. Positive means variables rise together. Negative means one rises as the other falls. Chi-square tests compare categories. T-tests compare numerical averages. Both tell you whether an observed difference is likely real or just due to chance. The p-value only measures surprise, not importance. A huge sample can make a tiny, meaningless difference statistically significant. Always ask, is this significant and meaningful? The null hypothesis, H, is the boring default, no effect. You can never prove H true. You can only find enough evidence to reject H. Think of it like a court verdict. Guilty beyond reasonable doubt. Type 1 equals false positive, alarm with no fire. Type 2 equals false negative, no alarm during a real fire. Which error is more dangerous depends entirely on the context. Without a control group, you can't tell if your treatment caused the result. That's why placebos exist. The real treatment must outperform thinking you were treated. Change only one independent variable per experiment. Otherwise, you won't know what caused the result. Everything else must stay constant. This is called controlling for variables. The dependent variable is what you measure. It depends on what you changed. Qualitative data captures what numbers miss. Many researchers combine both types for a fuller picture. Quantitative data is either discrete, how many, whole numbers, or continuous, how much, any value. The distinction affects which statistical methods and charts you should use. You've covered all 50 terms. Write down the one that was hardest to grasp and look for it in a news article this week. Statistics is a lens for understanding the world. Keep using it. Chart increasing.